Alright, we'll be there. Lindsay, we have an emergency, we gotta go. Alright, what's the problem? Construction worker took a 12-foot fall. Dr. Lindsay, I'm gonna need you to look at her papers.
Ow.
We're gonna need you to stay calm, ma'am, okay? Can you tell me your name?
Bobby.
What exactly happened?
I was working on a customer's roof and the wind hit me, so I took a fell.
It seems like our systems are really glitchy right now. We can't tell if your damages are serious until the system is up and running again.
Okay. I need you to tell me how far you fell from the house.
The hose is about 4 feet away, so 4 feet.
Okay.
So if we could see at what angle you fell down exactly and how high the fall was, we could see if it was hard enough to hit or rupture anything really serious.
So we're just gonna need you to wait for a second while we do this, okay?
Alright, come here, doctor. Let's look at the screen right here.
To find the angle on which Bobby fell off the building, we are going to take the height of the building and the length to which how far away she fell from it. These two numbers give us the measurements opposite to where she fell and adjacent to where she fell. To start solving this, don't forget to set your calculator on degree mode because that is essential to get the right numbers. Also, don't forget to hit the second tan for it to be the inverse because we are finding the angle. If you want to know why we are not using sine or cosine, this is because we did not include the hypotenuse in where she fell from, so this eliminates sine and cosine. Now that we are left with tan, let's go ahead and put it onto the calculator. Hit second tan, and then make sure you do 12 divided by 4 and close it with parentheses. If you didn't know, the second button is right here and the tan button is right there, which will make the answer inverse. After hitting enter on the calculator, you will get this number. If you rounded that, it would be about 71.57 degrees. So, now we know that the angle in which Bobby fell off the building from was 71.57 degrees rounded to the nearest hundredth.
Alright, so let's see. Okay, yeah. So, Bobby, it seems that you took about a 71-degree fall and you fell right onto your arm. So we're going to need to do some x-rays and make sure your arm is not broken.
Alright, so just sit tight. It's going to take a while, and we'll be back soon.
Okay?
Cool.
Alright, hello Bobby. We're just going to need to put a cast on you, so...
To find out the measure of Bobby's cast sling, we are going to use angle B. With this, we are going to find the measurement opposite of it, which is 11 inches. And we are trying to find out x. So, since the measurements we have is the hypotenuse and the opposite of angle B, we can easily eliminate cosine and tangent because they include adjacent measurements, but we do not have those. So let's set up sine. As you can see here, when writing the equation out, the sine 53 will be x, the hypotenuse. So we know that we are dividing 11 by sine 53. To plug that into the calculator, we'll do 11 divided by sine 53. After hitting enter, we get this as the answer. But before doing this, make sure your calculator is on degree mode, because then you'll get the wrong answer if you do not do it. So, after solving it, we get x is about 13.7735 rounded to the sling's hypotenuse, which would be about 14 inches.
I know, right? Whew, that was scary.
Guys, I heard there's a patient waiting in the doctor's office.
Did she need a shot? Why? Just a daily checkup or what?
I heard it's big. I think it's her first one.
Want to come check up on her?
Yeah, sure, let's go.
Alright. Hello, we're going to be your doctor today. My name is Sophia, and her name is
Lynn. So what's your name?
My name's Susie. My mom said I'm getting a really big shot today.
Okay, well, let's just take a look.
here are her stuff.
Okay, let's see. Yeah, well, it just looks like a routine vaccine. Sophia, do you think you could step out for a second?
Sure. We'll be right back. Wait, so what's the problem?
I haven't really put in a needle this big in someone yet. Can you help me find the angle that the needle will go in the person?
Yeah, sure.
To find the angle in which the syringe went into Susie's arm, we are going to find angle X. And as a bonus, let's just solve the whole triangle too. As we look at this triangle, we can see that we already have the measurements of the hypotenuse and the measurement of the side adjacent to angle X. Since we have the adjacent measurement in the hypotenuse, we're going to use cosine and not sine or tangent. When finding cosine, you put the adjacent measurement over the hypotenuse. So, as we plug in the numbers from the triangle, we put 20 over 55. There are two things you should remember when you plug this into the calculator. The first thing you should remember is to set your calculator on degree mode. And the second thing to remember is to hit second cosine because you are finding the inverse since this is an angle you are trying to get. So, after entering this into the calculator, you get that the measure of angle X is about 68.6763 degrees. Now, onto the fun part of solving the triangle, which means finding the angles and the sides. Since we already know that the measure of angle A is 90 degrees and the measure of angle C is about 68.68 degrees, let's find the measure of angle B. So what you're going to do is add them together and get 158.68. Then, by using triangle sum, you'll subtract this number from 180, which gives you about 21.32. So, the measure of angle B is 21.32 degrees. Now, let's move on into finding the measurements of the sides. We already know the measurements of side A and B, which is 55 centimeters and 20 centimeters, but we are trying to find side C. So, we'll do this by using Pythagorean theorem. When you plug these numbers into the Pythagorean theorem, you get a squared plus 20 squared equals 55 squared. And when you square those numbers, you get a squared plus 400 equals 3025. Then you subtract 400 from both sides and get 2625. And then you square root that, so you get a equals 51.2347. And that rounds to 51.23 rounded to the nearest hundredths.
Alrighty. So we're just going to give you a small little shot. It probably won't hurt much. Here you go. Let's see.
Okay, well, that looks, yeah, that's right there. So, see, that didn't hurt that bad. Need a little Band-Aid. And you're good to go.
Hello. That's great. Alright. Me and Dr. Lindsay will be over there right now. Alright, Susie, thanks for being such a great patient.
Bye.
Bye. Come on, Lindsay.